Hi everyone, welcome to the video. My name is Ajay Dhungel and today I'm going to talk about AWS PrivateLink, which is a service that AWS launched in 2017. And without further ado, let's get on it. So before explaining these points, I want to go ahead and show you guys the architecture of how AWS PrivateLink works. As you can see, we have inside the AWS cloud a couple of AWS accounts, and inside them we have different VPCs, and inside that it is a simple client server architecture where the clients are living on the consumer instances and the servers are here in the, let's say, producer instances. And what makes this architecture different from every other architecture that you see is that it does not use the public internet, which means that it utilizes the AWS internal network, and that is powered by AWS PrivateLink. And for that to work, we have to have a VPC endpoint of the interface type. There are two types of VPC endpoints, gateway and interface. Gateway we use for services like S3 and DynamoDB, and we can use an interface endpoint if we want to serve an endpoint service that we create on our own. Also one thing I want to mention is that AWS PrivateLink works with a network load balancer, so it is mandatory to have your network load balancer, and it needs to point toward your producer instances, or it does not particularly have to be instances. It can be Lambda functions or IP addresses, but you need to make sure that they are inside the VPC. And at the consumer side, you only have to create an interface on one of the subnets inside the whole VPC, and then you can use it from every other subnets on every other AZs inside that VPC. So let's go back to the slide here. So as you can see, PrivateLink is an internal network for your resources, and it can be anything. Like I said, your containers, instances, Lambda functions, and an internet network separate from the internet. And it is very secure because your data is not public, or it doesn't use any public network. And also it is very easy to configure, which I will show you in a while. And it is unidirectional. So let's go back to the architecture. Unidirectional in a sense that you can only request these producers from the clients, but there is no way for you to reach this consumer instance from the servers here. And this is different from VPC peering, because in a VPC peering, it is like a peer-to-peer architecture, while in AWS PrivateLink, it is more like a client-server architecture. And it is more important now than ever. I want to highlight this because AWS has started charging for public IP addresses that you use, so it is better if you limit it. I mean, AWS PrivateLink in itself has its own charges, but based on your requirements and your studies on uh, your own architecture, you can make a decision upon that. So, as we saw on this architecture, an AWS PrivateLink has its components, meaning it is not any standalone service that is available in the console that you can just click and figure everything out. So you have to create an endpoint service and interface endpoint across different VPCs. This can be on two different VPCs on the same account or across accounts. And the connection between the endpoint and the service is called an endpoint connection. So let's just say private link is the underlying connection between the service and the endpoint. Let's go ahead and do a little bit of hands-on demo. So let's start with, so I have my Terraform configurations here for the consumer and the server. So you know what, rather than looking at the code line by line, let's go to the console and see what services I have created and what are the configurations I have made. So let's start with the consumer account, and this is the consumer instance I have created, and this lives inside, there you go, this subnet, and this VPC is the consumer VPC, just to make sure. And in the consumer VPC, we have an endpoint of the type interface, and let's check in network interface here. So whenever we create a VPC endpoint, it creates a network interface of its own. We like to call it ENI in AWS. So this is an elastic network interface of the type VPC endpoint. And this resolves down to a private IP address in the subnet of its own, 10.0.68.231. So this is the interface that the consumer account will use to communicate with the producer VPC. So that's about it in the consumer account. Let's go back to the endpoint. As we saw the subnet here and the IPv4 address, and it also has a security group to allow certain traffic. We can also set up notifications, but we'll delve into that later. And every time you create an endpoint, you are given 2 DNS names or more, depending upon how many subnets you have. So endpoint can have a network mapping of multiple subnets, but for this one, I've only used one subnet because that is enough. So let's go back to the other account. This is the producer account, and there is another instance here. But before that, let's look at the VPC. So this is the producer VPC, and it has an endpoint service. So this is the endpoint service, and as I mentioned before, it has a load balancer of the type network load balancer, and it has allowed principal for the consumer account here, and this makes it possible for this endpoint connection. Usually you have to accept the connection here or reject it once you configure it. So I've already gone ahead and accepted it. And another thing that we need to make sure is that we need to check whether all of this configuration actually works. So for that, let's go back to the consumer account, and let's go back to the instance. So this is our instance, and we need to call the producer instance from this instance. And to access this from SSH, I have actually attached a public IP address, but it is not required for the private link. And here in this PowerShell console, I have it configured. So let's clear it first, and now we want to see if the private link DNS actually works. So let's go back to the endpoint and copy either of these DNS names. Let's go back to PowerShell. Now what we want to do is we want to curl it. So there we go, and it works. So this is uh, first page from the Apache server that you can get. Actually, I used a user data script on the producer instance while configuring it, so that it made it easier for us to crawl. Another thing we can do is we can do an ns lookup on this DNS, and as you can see, the same private IP address of the interface here. So now that we know it works, another way to uh, make sure that the whole configuration works is that the state needs to be available, and always make sure that you have allowed the principal. And let's also see the whole network on the producer side. So as you can see, here is the main load balancer, and it points to an application load balancer. So listening on these two ports, I have the same target group for both, and it points to the application load balancer, which again has its own targets. So if we go back to the application load balancer named app, you can see that it is also listening on port 80, which finally forwards to the producer instance. So the health check is unhealthy, but that shouldn't be of concern as long as the instance is running. And as you can see, this is the same instance that is giving back this response. So that's all about AWS PrivateLink. I found it much easier to set up, and you do not have to configure any route tables for any of the subnets because it is all internal. And apart from that, it is also unidirectional. So if you need in your architecture for both resources on both the VPCs to call one another, then maybe VPC peering or a transit gateway is the right service for you. But if you want something like that, a client-server architecture on an internal network that is PrivateLink, then go ahead with PrivateLink. So thank you for now. That will be all. If you have any questions, please let me know in the comments section or message me below, and see you around.